So I have the complex number cosine of 2 pi over 3, or 2/3 pi, plus I sine of 2/3 pi, and I'm going to raise that to the 20th power. And what I want to do is first plot this number in blue on the complex plane, and then figure out what it is raised to the 20th power, and then try to plot that. And I encourage you to pause this video and try this out on your own before I work through it. So let's first focus on this blue complex number right over here. It's clearly written in polar form, and the angle is 2/3 pi, or 2 pi over 3 radians. And its magnitude of this complex number is clearly 1. And to make that a little clearer, you could write it in kind of the pure polar form where you have its magnitude out front. So it's cosine of 2 over 3 pi plus I sine of 2 over 3 pi. So you could write it just like that. And when you look at that, the angle is 2 over 3 pi. And so that would get us, let's see, this is 0, this is pi. We're going to go 2/3 of the way to pi. Each of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of these is pi over 12. So we're going to go 2/3 of the way would be 8 pi's over 12. So 1, 2, 3, 4, 5, 6, 7, 8. And the way I was able to reason through that is that 2/3 pi is the same thing as 8 pi over 12. Each of these segments is pi over 12, so I just counted 8 of them. So that's that number. But now let's try to raise it. Now let's try to raise it to the 20th power. Let me clear this. And to do that, we're going to use Euler's formula. And Euler's formula, you might remember, tells us that e to the I theta is equal to cosine of theta plus I sine of theta. And so you see right over here, this is already written in that form where theta is 2/3 pi. So we can rewrite what we have in blue here as e, let me write it over here, as e to the 2/3 pi I. And then, of course, we're raising that to the 20th power. We're raising that to the 20th power. And this simplifies things dramatically because here, if I tried to multiply this thing, if I had 20 of these things and I multiplied them together, that would get really, really, really hairy really fast. But here I can just use exponent properties. This is going to be the same thing as e to the, if I raise something to exponent and then raise that to an exponent, I can just take the product of the exponents. So this is e to the 20 times 2 over 3 pi I, which is equal to e to the 40 over 3 pi I. Now, this is this number raised to the 20th power, but this is an awfully large angle right over here. I mean, if we're thinking 40 over 3 pi, let's just try to digest this. 40 over 3 pi, this is the same thing as, let's see, 40 divided by 3 is 13 1/3. This is the same thing as 13 1/3 times pi. And we know that going 2 pi radians gets you around the unit circle once. So this is going over 6 times around the unit circle to get to, or around, I should say, not the unit circle, or going 6 times around the, I guess, going in circles in order to get to the point we want to. So in order to simplify this a little bit, let me subtract the largest multiple of 2 pi that I could figure, that to kind of get this in as small of a form as possible. Because we know an angle, if we have some angle, it's equal to that angle plus some multiple of 2 pi, where k is any integer. So k could also be negative. We could be subtracting a multiple of 2 pi. So let me subtract, let's see. The largest multiple of 2 pi that I could subtract here is going to be 12 pi. So let me subtract 12 pi from this. So if I subtract 12 pi, so I'll do it down here. So 13 1/3 pi minus 12 pi. Remember, I'm just trying to subtract the largest multiple of 2 pi that I can. So minus 12 pi is going to, oh, whoops, I already wrote pi. Minus 12 pi. 13 1/3 minus 12 is 1 1/3. That's going to be 1 1/3 pi. Or we could write it as 4/3 pi. So this complex number is going to be equivalent to e to the 4/3 pi I. And this makes it much simpler and much easier for me to plot. So 4/3 pi, or the same thing as 1 1/3 pi. So this would be pi, and now we have to just go another 1/3 pi, and each of these are twelfths. So if we go 4/12 pi, so each of these are pi over 12. So we go 4 pi over 12. So 1, 2, 3, 4 gets us right over there. And so this number is the 20th power, is this, which is equivalent to this, which we've plotted right over there. Now, what if we wanted to take it to, let's say, the 21st power? Well, then we would increase the angle by another 2 pi over 3, or 8 pi over 12. So we would increase the angle by 1, 2, 3, 4, 5, 6, 7, 8, and we would go right over there. So how does this make conceptual sense? Well, the number to the first power was right over here. That was our original number in blue right over here. If you raise it to the second power, then you're increasing the angle by 2/3 pi. You're increasing the angle to go there. You raise it to the third power, you increase the angle by 2/3 pi, you go over there. Fourth power, you get back here. Fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th power gets us right over there.